Hi guys, welcome to this channel. If you wish to start your first exploratory data analysis, then this video is just for you. We'll get to know functions and attributes useful in data analysis. Some screenshots from libraries documentation will be provided, so that you get familiar with reading and searching for them. We'll use house price prediction dataset from Kaggle. All links will be in the description box down below. You should have your Jupyter Notebook installed to follow this tutorial. Let's start with importing two basic libraries, which are pandas and matplotlib. As you may notice, we add import something as something, so that in our code, when we want to access functions from the library, we don't need to write the whole name, but just a shortcut. Our first function is read CSV from pandas library. It allows us to read CSV file and store it in a variable as pandas data frame structure. We access this method by writing our shortcut pd, then .readCSV, and in the parentheses we provide essential parameters. As you see, there are many parameters that you may provide. We'll focus only on one of them, which is the path to the file. We write the name of the file and relative path to it from current notebook. As you see, my data is in the same place that my notebook, as I provide only the name. Let's move forward. Two useful data frame functions for the start are head and tail functions. By default, they return first or last 5 rows of a given data frame. Here we get first look at our data. We see many different columns like date, price, bedrooms, bathrooms, etc. And we may change the default value, and if we want to see first 10 rows, we just need to write here 10 in parentheses. Similarly works tail. It just gives us the last 5 rows by default, and if we change the number here, it will return a chosen number of last rows of our data frame. Let's see the shape property. It simply returns the number of rows and columns in given data frame. In our case, it is 4,600 rows and 18 columns. Now, very useful function that generates descriptive statistics. We get in one place a lot of information of each column that has numerical values. For example, let's explore bedrooms stats. We see the count value, which is the value that tells us how many samples of data is in this column. And as it was with shape, it's 3,600 samples, same number as the number of rows present in data frame. Then we get the mean value of bathrooms based on the whole dataset, which is 3.4. Next, there is a standard deviation if we need it for some reason, and minimum and maximum value, which provides us with a range of possible values. So we can know now that the bedrooms in our dataset are between 0 and 9 inclusively. In the end, we get quantiles if we are interested in understanding even more the data from a statistical point of view. Now shortly about list function. When used on data frame, it returns the list of all names of present columns. It is helpful when there are many columns and you want for some reason to get the names easily. dtypes is another data frame property that can be used to provide essential knowledge to us. It returns data type for each column. While transforming data or building a model, often the type of our data plays a crucial role. So we need to know how to get the information about it. In our case, most of the data is numerical. We get float and type, but also object type. In the end, let's see some visualization. Using matplotlib library, we can get some nice results. Here I chose scatter plot to see whether there is a relation between the size of a house and the price. Scatter allows to see individual points, so when the time of occurrence is of secondary importance, then it's very useful. plt is our shortcut, so that we don't need to write the whole matplotlib.pyplot to access the scatter plot. There are many optional things that you may set. I set just the title, axis names, and also the size of the plot. Boxplot plot shows how the data is distributed. In this case, I wanted to see how the price is differently distributed according to the condition that the house was in. Here is the explanation of how to interpret this box plot. We see the minimum and maximum values in a given category. The box provides also the information about quantiles, and our box plot shows also outliers, points that were signed as anomalous from statistical point of view. Because of these outliers, our box plots are not very readable. Let's get rid of them and see our data better. Now we see clearly how the price distribution is in different condition categories. For example, condition 5 has, of course, the highest price. But what may be surprising is that the difference between condition 1 and 2 is not so significant, and even when you get house in condition 2, you may pay less than for the one in condition 1. You could say that we may simply get the mean value of the price for condition 5 to have some knowledge about it. But compare having the mean to the real distribution. There were prices below 400,000 and above 700,000 as well. The mean value that we got here is not as informative as this box plot can be. If you want to learn more about boxplot, I provided the link to a nice explanation from Simply Psychology website. Number 9 is a correlation function. You may say that it is a statistical method to demonstrate the relationship between two variables. The range is between -1 and 1, where -1 is the strongest negative correlation, so as one variable increases, the other decreases, and +1 is the strongest positive correlation, so as one variable increases, the other increases as well. 0 means there was no correlation observed. It is a useful measurement to help us select features for simple models like linear regression. In our case, if we wanted to predict the price of a house based on one variable, we could choose, for example, square feet living, because, as we see, this correlation is the strongest. In the end, let's see how to take only chosen columns for further exploration to store them in a new variable. Log property allows us to access chosen columns and rows by defining the range of both of them. In our case, we want all rows and columns starting from price and finishing inclusively with square feet living. We could achieve it similarly using ilog property, but then defining the column indexes that we are interested in. So now we don't use the name, but the number of index. Remember that index in data frame starts from 0. So if we want to omit time in our new variable, we have to start from 1 because time has index 0. So another option when you want to choose columns that are not next to each other, but they are in different places in your data frame, is to simply use square brackets, which allows you to choose columns by name, and you don't have to worry about their index or whether they are next to each other. Hopefully you found this tutorial useful. Let us know in the comments if you have any questions or ideas for future videos. Stay tuned and see you very soon.